right, thanks a lot. What an introduction. Thank you very much. It's great to be here. And yeah, so I hope everyone can hear me because I don't see any confirmation from that. But anyway, so let's get into it. So basically, you should be able to have DevNet running. So that should be running like something like this. And there could be a chance that it will be dropping out. And if that is the case, then just restart it, because sometimes the Docker container timers and the timers of your local network or the DevNet are not in sync. So just restart it and make sure that it runs again. So once you did this, you should be able to have already connected to Wallet Connect, or to Ecko Wallet. And what I usually do is I open the Wallet Connect in a separate view, so expand view, so that it doesn't drop out every time you switch to a different area. And you probably have added the connected the network. So basically here you have the local DevNet. I named it local DevNet. I think this is not very important. It's just the display name that you see here. And then you have this URL. And I noticed that it might be that you should not add the slash, because they add the slash for you. And then the same one for here. And the network ID is actually important because this is the one that we match when you are making transactions. So when you did this, you should be able to have created a wallet. And a wallet is actually an account. So an account is being created by clicking on these three dots and then clicking the create wallet. So I can do this again, which will now give me an extra wallet. And this wallet is being generated based on the private and public key pair that's being generated from the 12 words that you have received. So this is I just created this wallet temporarily, so I can do export recovery phase. Don't do that in public, because usually you don't want to show that to anyone. And then you get to fill in your password. So you have set a password. So this is the hidden one. So I can copy it and then paste it somewhere else in another wallet and then reuse this, because actually this is the one that is generating your private and public key pairs. So make sure to store this one if you have actual money on there. And this is actually the one that is also being used for DevNet, testnet, but also like the real mainnet. So don't make sure that you use either separate ones if you just want to make sure that you don't spill your money to someone else accidentally, and use different ones for testing and then deploying. All right, so that's about it. Then after that, once you click this little string, you get the K account. So the K account is actually the account where the money is being stored. So Doug told us that it's just a ledger with a number, and this is actually your identifier for that record, basically. Now, if you want to fund your wallet, so now it has 0 money, you can go to the project, and the project has a nice. So let's open the project here. It has a nice package JSON with a lot of scripts that you can run. So one of those scripts is Kadena fund. So if you execute Kadena fund, so I'm using pnpm, but you can do npm run or John, I think run, and then run Kadena fund. And once you've copied that, you can paste the account name. So now I pasted this account name. So this is the account that I want to fund. So then I press enter, and the public key is actually just the same, but without K colon. This is only true when you just create an account, probably via a wallet. So this is not a given that this public key is the one that is actually the one that is owning this account. However, I don't want to go into technical details, but yeah, that's how it works. So now we are actually sending a transaction to the faucet. A faucet is a thing that gives us money, and then it should have money on there. Now, as you can see, this transaction has been picked up by the blockchain. This is actually a mock of the blockchain that is running, and it's actually, so Doug told us about the real blockchain is actually showing a new block or calculating a new block, the difficulty of the block is as such that it will take 30 seconds. So in this case, we have set it to 5 seconds. So we made it a lot more easy to solve in order to, get it running fast when you're working on it. All right. Now, let's go into the actual exercise. So the exercise is, I think, exercise 2. Well, it's 0 index, so it's exercise 1. And you probably want to connect to your wallet. So from here, you can go to login, and then you have to set up your email. And if you didn't, you did need to sign up. So I did that. So let me just log in here. I think I just copy pasted this. I think I didn't start my local environment yet. Let me just quickly start that. Let me start it from here. Yes, of course, I didn't start it because I was showing the funding. So now that I started it, you can see that it's running on localhost 3000. And you saw the page refresh as well. So let me just log in here. All right, now that I'm logged in, I can see some information that's coming from the database. If I want to connect, I need to go to my profile, because actually if we want to connect because we want to be able to create a project. Well, this is something that you will implement in a further stage, but before we can do that, we need to make sure that you have your wallet connected. So let's go to profile and click connect your wallet. And here, what will happen is it will open a pop-up and it will ask you if you want to connect your wallet here. Because what happens is that the connection needs to be there in order to identify how much money you have and to create the project that you want to crowdfund on the blockchain. Because the blockchain is actually handling all the information that has to do with money. Now let's see, okay, if I connect wallet, so here I can select which account I want to use. So let's say I want to use the 07B account and then click save. So now that you see that, it is connected. Now the current balance is incorrect because this is just a mock value. So what we're going to do is we're going to create that. So let's hop over to my editor and go to the use wallet. So the use wallet function is actually empty here. So we see you can add something like this, and it should change here as well once we have connected our wallet. It's not really connecting, so let me see, did I do something wrong? Oh yeah, there it is. So 1337, well, that's incorrect, of course. So if we go back, and so what we're gonna do, we're gonna use the Kadena client. So the Kadena client is like, if you've used Prisma before, you know that you can use Prisma to generate a type-safe client in order to work with a database. Well, essentially, well, Doug told us it's not really a database. It's more like a data store. So we have some keys that we can access based on some queries that we can do. Well, the query is actually not really a query, it's just a function. And in order to get all these functions, let me just show you that. So every daemon gives you a function. So this is a function. And this function current time returns the current change block time in time type. Well, there's also other functions that we can do. For example, like a cancel or refund, a project ID, or open a new project, or make a project fail, etc. So these functions we want to access. Well, in order to do that, we first need to create our transaction, because everything works with a transaction. So let's make the transaction that will retrieve the balance from the blockchain. This actually doesn't cost money because we're only doing a read, and this read will be done on a node that is just providing this information. So get balance transaction back.builder.execution, because we are going to do an execution for this. Now, the first argument is actually the command that we want to give. And usually I would, pass in something like a get balance. However, as you can see, this is not working because it doesn't exist on iPack modules. So if we command click on this, you can see that we have inside pack, we have the modules, which is actually the one that we saw here, pack.modules. But if you go there, it's empty. So what do we do? Now, we need to create this. So if we go to the package.json, we can see that we have this contract generate function. This is actually what we're going to use. But we're not going to use it this way, but we're going to change it a little bit because we want to work with the coin module. So what we're going to do is change the contract to be coin and then press enter. So this will actually, from the blockchain, it will fetch the contract, the smart contract that is the coin contract. And then it will fetch all its dependencies and then write a few files. What the interesting file is that once we go to the generated coin.dts, you can see that we have a bunch of things here. Let's go to the function that we actually need, which is called getBalance. So if we go here and search for getBalance, we see that there is a function which needs to be passed an account and it will return something. And it's something we will talk about. But before we do that, we need to refresh TypeScript. And you can do that by pressing Command-Shift-P or Control-Shift-P or Command-P, Control-P, and then creating a greater than mark character and typing restart TS server. Because TypeScript doesn't know about this one being generated. And now, if we type this again, we can see we have actually coin here. So if we generate coin and then press dot, we can now see that there is a bunch of functions available. So what we want to do is get balance. And then we want to pass in an account. And the account is actually account.value because that's the one that we got from connecting the wallet. Now, in order to do this, we need to add some more information because this is not a full transaction yet. So what we want to do is we want to press dot after the closing brace here. And now we want to say, okay, we want to add some meta information. The meta information is nicely typed. So we want to get the chain. And that's probably chain 0. And we want to enter some more information, which is, I think, the sender. The sender will be the same as the account because sending is actually the one that is paying for the gas. So, and an account is paying for the gas in this case. Chain ID actually needs to be a string. So that's really nice because we can get all this information. Then we want to add some more information. For example, the network ID, which is fast development. And that's about it for this one. So now we want to say create transaction. So now we have an actual transaction here. But how are we going to send this to the blockchain? So we are going to create a client. And what we're doing here, we need to get this client based on the information that we have. So the client is actually running an API. The client needs to connect to the Chainweb API. And the Chainweb API is hosted on this URL. So the URL is actually the same as we used before, but there is also a bunch of APIs hosted. And in this case, this is the one that we want to access because we are going to send packed commands. So that's the one that we use. So now from here, we can actually also include the network here. So network ID is the one that we used here, so we can actually reuse that here. ID. Now, in order to get that information, we can do a dirty read. So client dot, because we are not actually sending a transaction to the blockchain to be executed fully and then store its information there, but we're just doing a read. And the read is actually the transaction that we just built, so the get balance for the current account. Now this will return a promise, so we need to await that. So there will be a command result as a promise. Now inside command result, we can see a bunch of things. We actually need to await it, otherwise we won't get it. After that, we get a result here. And the result has a status, and the status we need to check. So if we do, if status is...
Hey, Albert, real quick,
Yes.
Can you increase the font size so we can see it a bit clearer?
Of course, yes.
Oh, beautiful. Thank you so much.
Yeah, no problem. So here you can see that we are actually checking the status. And because TypeScript works very well, we can now also see the information that we got from there. So let's see if we retrieve the data from that. So command result dot data. And this is the one that we're actually going to use as a balance value. So now we're going to say balance value equals this. And as this is not a string, but a packed value, we need to cast this as a string. And this should actually make sure that we can do a transaction. So let's see if it actually works. Oh, there it is. I have 100 KDA because I just funded this account. And this is the way how we interact with the blockchain. And if we go to network, let me increase the font size a little bit. And we refresh this, you can see that there's been done a local call. And one of those local calls is actually the call we just made. So let me clean this and then see if we can just trigger a re-render here. So this is the coin.get balance that we actually did. So you can see the public key here. So this is the public key, and this is the account that we just fetched information for. So if you look at this, you will see that a transaction actually has three properties: a command, a hash, and a signature. And we talked about hashing, and this is actually the hash of the command that we sent. And in order to verify that we are sending this command, we need to sign it. However, in this case, we don't let the server validate the signature because we only want to read. So in this case, that's not needed. And then if you go to the preview, we'll see that inside results, you see the status is successful and the data is 100. So that's actually what we see here. That's basically what the exercise is. And there's just one thing that I want to mention is so currently we have authenticated with username password. But there is also another way, because essentially, because we can use the wallet and have something from the server, have the user sign that, we can actually make it such that we can authenticate without email and password, but just with some information that we have in a wallet. And I have a small example of that, and I just want to show that. Let me quickly turn this one off and then enable this one. So if you log in and you click connect your wallet, so now I have no Superbase user, but if you connect your wallet, well, it's already connected before, and then you can see that I'm connected here. So let me disconnect it and do it again. It will pop up the connection again. And because I had this already connected, I don't need to select which account I want to use. So if I go back to the Ecko Wallet and I'm going to reset this with the connected sites and remove this, it will be logging out. And now if I refresh this, it will ask me if I want to connect. So in this case, I can connect with this account here. And this is actually a really nice way to make sure that the user is really protected from, spam. You don't drop his email anywhere. You don't need to store passwords because, storing passwords is basically a bad thing usually. That's why we use OAuth or everywhere, or, log in with Facebook, log in with something else. So yeah, that's basically what I wanted to show you. Yeah, I think it's time for questions.
Fantastic. I am looking forward to it, that we have our questions ready. So to start with, let's see. We've used Ecko Wallet in the project. Can you integrate Kadena in other wallets?
So we used Ecko Wallet in the project. Can I integrate Kadena with other wallets? Yes, that's very much possible. So currently we have a Kadena wallet, actually Ecko Wallet, and we are actually using the Wallet Connect to connect to other wallets. So if you want to use other wallets, you can also use Koala Wallet. So that's actually something that they just recently released. Maybe, can I share my screen again? Just so I can show you a little bit about that. Let me see. Sorry. All right, so this is Koala Wallet, and they recently released, and we wanted to actually use this one with Wallet Connect because Wallet Connect can integrate with a lot more wallets because it's a standardized way to connect. And once you log in, it looks really nice. So let me just open this in a separate tab. Let's see. And here you can, see your information, how much money you have. You can create new accounts, and you can, do a bunch of apps. So you can connect to a bunch of other apps as well. And those are all integrated within one app. And that's really cool because, for example, KMC, Kadena Miners Club, I have a miner myself and I can look into this and log in with my account. And here you can see, for example, the ways that you can log in. And this is actually, so currently I'm logged in with Chainweaver, which is our development wallet, but you can also use Zelcore or, Wallet Connect, which connects to a bunch of wallets, and EckoWallet. But there are more wallets, definitely.
Very cool. Thank you for showing us that. Next question for you is, what's the benefit of funding a crowdfund project on the blockchain instead of with traditional Web2 tech?
Yeah, so basically, when you're using Web2, like Kickstarter or Indiegogo or something like that, right? And they are centralized. So you have to trust that party that they will, hold your money only until it's actually, the project is funded. But here we can actually make it such that the blockchain, whenever a certain threshold is, met, only then it will fund all the end users. The producers of this project. Another big advantage is actually when you are building a app or a web application that has to use Stripe or some other payment provider, that's actually very, very costly. Usually you pay like 25 or 50 cents per transaction and then a percentage of that transaction. So if you're actually, for a pair of glasses, that's fine. But if you're actually, buying something of like 1,000 euros or maybe even more, then 3% becomes a lot. And especially if you also do like very small transactions, this 25 cents, those add up. And it's really a burden, for your users to, pay that. So those are a few of those, advancements. And don't think that it's only needed to have it only on Web3. I mean, Web3, you should treat the Web3 part as, a ledger. It's something that's really secure, really safe, and it gives trust to the end user. And in case of Kadena, it's really cheap. And then you have your own, Web 2 part, with your Supabase or Firebase or, Postgres database with all your information and your pages and your images, etc.
Very cool. Thank you. And I think that does lead into pretty well of like, do you have any cool case studies that you could share about Kadena?
Yeah, so there's a lot of cool projects. One that I really like is the Kadena Mining Club. You can actually so what they did is you have NFTs, but attached to the NFT, which is just a token, right? It's on the ledger. It's registered that you own something, and this something indicates something somewhere else. And this connection that you own something somewhere else is actually a real miner. So the Kadena Mining Club, you can buy a NFT, which actually converts to owning a miner, and that miner is actually running and generating money. So I think they have miners of like 3 terahashes a second, and that will generate some money over time. It's of course it's not as much as you would have your own miner, but it's a nice thing. Recently, actually, I heard of a very cool project of international shipping, where between governments something of very high value was shipped, and it was tracked on the blockchain every step of the way. So sensors were just pinging the blockchain to send transactions and make sure that whatever you are sending is actually trackable. So those are also really nice use cases.
That's pretty cool. Yay. Okay. This project shares Web 3.0 and traditional technology. Would it be feasible to build the project entirely on top of Web 3?
Yeah, I basically touched on this a little bit, but it would not be feasible. So there are actually ways that to use distributed databases, but Kadena is more of a ledger, and it's not meant to store huge amounts of data. So it's not. So if you have something that is really low profile and it doesn't have a big footprint, then you can do the whole thing on Web3. But you must realize that also like retrieving data is also different from a regular endpoint, right? So it needs to execute some code, and usually you would probably want to have your own infrastructure for that part as well. So in order to make it, load balanceable and high performant. So if you're, firing 10 or 20 queries to the blockchain and you do that from 1,000 users, that will add up really quick because it's not made for that. So for that, actually, we have, if you actually want to receive information, we have a Chainweb Stream, it's called. This is a streaming server that you can listen to specific events that happen on the blockchain. So for example, if you want to listen to the coin.transfer event for your specific account to see how much money people are sending to you, that is something you can do very easily with that.
Very cool. Great. And where did the value of the client ID come from in the code?
The value of client ID, I need to check that one. I don't think.
If it's easier, you can just reply on the chat on that one.
I don't think I have client ID. I have chain ID actually. Maybe that's the one that's mentioned. So chain ID is actually being passed in from the transaction. So this client has a few functions. So let's show it this way.
Here, let me add it back to the stream. Yeah. Here we go.
So I'm not sure if you're talking about maybe chain ID, but chain ID is actually part of the transaction. So the transaction is being generated here. And yeah, what we can do is, so here we have a bunch of things. So dirty read is one. And this is just a function that's being generated from the client. And whenever you call a function here, so send or submit, local or some other function, it will add, it will actually call the endpoint, and it will generate the URL based on chain ID and network ID. So if I would want to use this same client for another transaction, let's say I want to make a move money transaction, I could change this into coin.transfer and then have a sender, receiver, and an amount. Something like this. Now I do another transaction, and I can actually reuse this same client because the client has all the information it needs. And maybe I want to do that on chain 10 or something. But now I can still do a submit with the move money transaction. It gives an error because this one is not signed yet, and that's something that you will go over in the next exercise. But when it's signed, then it will be able to submit it to the blockchain. And then it will actually be executed. So the receiver will receive 10 Kadena, and the sender will be deducted 10 Kadena.
All right. And hopefully that helps, especially since it was a little different, but I'm pretty sure that's what they were talking about. What does the dirty read do?
Right, yeah. Dirty read is actually a alias. So you can see if you hover over this, you get nice documentation. So it's an alias for local when both pre-flight and signature verification are false. So basically what we do here is we make sure that the gas cost is not being calculated because that's what pre-flight does. And signature verification is not being verified. So if I would do a regular local call, so if I would do local here, and let's go to the here. I'm not sure if it's, yeah, it's still on, so. Now you see my wallet is 0, and the result is that there is a packed internal error and the buy gas is failed. And that is because I didn't limit the gas. I didn't say anyone should pay the gas, and I didn't sign this transaction. So basically dirty read is the same thing as a local with some options where pre-flight is false and signature verification is false. So now we should see, yeah, now it works again. So that's basically just an alias.
Oh, very cool. Okay. And a last question we have is, this contract we use, like the coin one, is like a template. Is that like a template? These contracts are already structured to be used in different use cases.
Yeah, so the coin contract is actually like the one of the first contracts that is being built, you know, on the blockchain. It's actually a contract that cannot be upgraded, but we also have so it's not, if you mean a template, it's a template for fungibles, and a fungible is something that can be split up. So a token that can be split up in parts, like a regular non-fungible token, an NFT, cannot be split up in parts. If you have an image, you cannot split that up. But a coin can be split up into 0.0000, some bunch of zeros, 1, and then it's split up in fractions. Now, I'm not sure if I understand this right, but not all the contracts are the same. So you can make a contract. So if we look at the crowdfund contract, this one is actually built fairly differently. And it's actually really easy to read. You just have to, you know, understand a little bit about what the keywords mean. But yeah, we have actually a learning platform. It's on academy.kadena.io. And there we have a really nice tutorial to build applications and to build smart contracts. Yeah. There's
Very
also,
cool.
yeah. There's actually one more thing I want to mention, and that is
For sure.
for everyone to know, is that when you go to viewforge.kadena.io, we actually have an NFT that you can claim. So once you have created your K account inside the wallet, you can use this one and paste it in here, and it will be sending an NFT to you. And this is actually the NFT that you own. And I think there's a limited supply, so make sure you do that really quick. It's on viewforge.kadena.io. I will put it in the chat as well.
I'm just thinking, I was like, I need to go do that too. And make sure that I get it. Well, great. Thank you so much for your time today, Albert. And that goes with all the questions that we have for you today. Thank you.
All right. Awesome. Thank you. Thanks a lot.